In this video, we're going to be naming simple alkanes. IUPAC has given us some strict rules when it comes to naming organic compounds, and it's led to monstrosities like this one. But don't worry, common names are given to many intricate compounds. However, being able to name simple organic molecules using IUPAC nomenclature is an important way for scientists, teachers, and students to communicate the language of organic chemistry. Alkanes are organic compounds that only contain single bonds between carbon and hydrogen. They form the backbone of organic chemistry. The first thing we need to do is to learn how to actually read line angle structures. Here are two steps when looking at structures for alkanes. We'll take a look at this compound to be our example. First off, each vertex and end represents a carbon atom. It's much faster to make zigzags on your paper instead of writing out each bonded carbon. And secondly, each vertex and end is assumed to be bonded to enough hydrogen atoms to ensure that the carbon has a formal charge of 0. Since carbons like to have 4 bonds, an end carbon will have 3 hydrogens attached to it, and a vertex carbon will have 2 hydrogens attached. Now I think we're ready to name some simple, non-branched alkanes. We want to first count how many carbons there are in this line angle structure, and then use a Greek prefix like hexa or penta to specify the number of carbons. Then we attach ane to the end of the word. For example, in this structure we count 6 carbons, meaning we use the prefix hex and end with ane. Therefore, this compound is called hexane. However, there are some names you must memorize. Non-branched alkanes with 1 to 4 carbons are given the names methane, ethane, propane, and butane respectively. In order to name more complex alkanes, we must know what alkyl groups are. A normal alkyl group is created when 1 hydrogen from an end carbon is removed from a straight chain alkane. The removal of this hydrogen changes the name ending from ane to -yle. An example is the removal of a hydrogen from methane, CH4. When we remove 1 hydrogen, it now becomes a methyl group. Likewise, removing an H from an end carbon on ethane will result from an ethyl group. Replacing the removed hydrogen will now be other alkyl or functional groups that are able to bond with the carbon. We designate this generic group with the letter R. We can think of it as just a placeholder. This is important when we start bonding these alkyl groups to other functional groups. Furthermore, 2 very important substituents that should be memorized are the isopropyl group and the tert-butyl group. These are different from other groups we just named because 1 hydrogen was instead taken off a non-end carbon or branched alkane, ultimately making these twig-like structures. With alkyl groups defined, we are finally ready to name alkanes with substituents. Here are the rules. First, you must identify the longest continuous carbon chain. Let's see. We can circle this chain here that contains 2 carbons, but I think we're able to find a longer chain here. I count 6. How about this group? I also count 6. From this, I think the longest continuous chain we have for this compound is 6 carbons. Now count up the number of carbons and identify the core name for this compound. In this example, our longest chain comprises 6 carbons, meaning its core name is going to be hexane. Now we must number the core chains so that the substituents are in their lowest positions. Let's start by numbering from right to left. As we can see, the substituent is located in the 2nd position. Now let's try the other way around from left to right. Our substituent is now in the 5th position when we number the chain the opposite way. Since we want to number so that our substituent is in the lowest possible position, being in position 2 is lower than being in position 5. Therefore, we will label from right to left. It's time to name our substituents as alkyl groups. For this one, there's only a branch that comprises 1 carbon, meaning we have a methyl group attached to the core chain at the 2nd position. It's finally time to build our name. Hexane will be our core name, and then we attach our substituent name to the front along with its position. Use hyphens between the substituent name and its position. In this case, our final compound name is 2-methylhexane. It takes a lot of practice identifying and labeling the longest carbon chain. An interesting thing to note for this compound is that since we have a tie between 2 6-membered carbon chains, the methyl substituent is also in the same lowest position even if we use the 2nd 6-carbon chain. Therefore, you can also name this compound 2-methylhexane with the 2nd identified chain, and these two are equivalent compounds. Now it's time to name a more complex alkane. Again, we start by identifying the longest core carbon chain. This chain has 3 carbons. This one has 6, which was our longest in our previous example, but this compound actually has a longer chain with 7 carbons. So in this example, our longest will be a 7-carbon chain, giving this compound the core name heptane. Next, we identify our alkyl groups. Looks like we have 1 methyl and 1 ethyl attachment. Then we number our carbons so that our substituents are in the lowest numbered positions. If we number from right to left, we see that the ethyl and methyl substituents are in the 4th and 5th positions respectively. However, if we number from left to right, we now see that the ethyl and methyl substituents are in the 3rd and 4th positions respectively. These positions are therefore lower than numbering from right to left. 3 and 4 are lower than 4 and 5. Now we build our name. Heptane is tagged at the end since it is our core name, and we put our substituent names and positions in the front. Remember to use hyphens between a substituent and its position. We also must use hyphens to separate different substituents from one another. So there's a hyphen between 3-methyl and 4-ethyl. It may be tempting to say that this is the correct name for our compound, 3-methyl 4-ethyl heptane. However, this is wrong since IUPAC nomenclature states that we must alphabetize the substituent names rather than ordering their numbers. Therefore, our compound will instead be called 4-ethyl 3-methyl heptane since E comes before M in the alphabet. Finally, we're going to look at an example of a compound containing multiples of the same substituent. Again, we identify our longest continuous carbon chain. In this case, it will be 8 carbons long, so our core name will be octane. Now number our core alkanes so that the substituents are in their lowest possible positions. For this one, we're going to label from right to left. We now see that we have 2 ethyl groups in position 3 and 5. According to IUPAC rules, when there are multiples of the same substituent attached to a core chain, we use the prefixes such as di or tri in front of the substituent name to identify the number of copies. In front of the alkyl name will be their individual positions separated by commas. So for this compound, our name will be 3,5-diethyl octane. 3,5-diethyl shows that there's 2 ethyl groups in the 3 and 5 positions on the core carbon chain. If more unique substituents were added to this compound, you would disregard the prefix on the substituent when alphabetizing. For example, in 3,4,7-trimethyl 5-propylnonane, the trimethyl substituent would be named first since we ignore the tri prefix and just compare the substituent names. M comes before P in this case. We've learned how to interpret basic line angle structures and name alkanes. Again, here are the IUPAC rules to remember. 1. Identify the longest continuous carbon chain. This will be the compound's core name. 2. Number the core chain so that the substituents are in their lowest number positions. 3. Identify the alkyl groups. 4. Build the name starting with the core name tagged at the end and add substituents in the front, specifying their location. Make sure to use hyphens. And 5. Make sure these substituents are alphabetized. If you found this video helpful, like and subscribe for more. Thanks.